We're all at least somewhat familiar with percents insofar as we have to deal with percents fairly often when we buy things, having to pay sales tax. Even better if we can get something on sale and there's, for instance, a 25% off sale going on. So how do we deal with percents when we're outside the realm of what we might be most comfortable with? And what we want to do is rely on the word percent as a bit of a clue. Percent, chop that sucker in half, and what we get are two pieces, the meanings of which provide us with that hint. Per. We're used to hearing that sort of thing as far as a ratio type of thing, miles per hour, for instance. So per relates to this idea of a ratio. So a fraction bar, or saying something like over. Then the other half of the word percent is cent. Now we're used to that in terms of money, where we would want to think, well, cent means penny, 100 pennies in a dollar, so 100 in a whole thing. We could also use that word century to kind of jog our memory that century is 100 years, so the number 100 is important as far as working with percents. So out of, or for every, or we could just say very plainly, over 100. That might be enough to just go ahead and kickstart the things that we might need to do when we're working with percents. And that does really give us about the fastest thing that we can do, where we take a percent and just write a ratio version of that. So that's something that's quick and usable for us. Now it's also possible to, because of the ratio, create fractions that are based on percents. And because we can convert fractions to decimals, then we can have the decimal version as well. As far as the word percent, the fraction version would be 1 over 100. As far as the word percent, the decimal version, 0.01. So to emphasize with a specific example here, the long and drawn out version of what we would have going on, well, might be longer or shorter depending on what we're trying to work out. 23.4%. The quickest thing for us to do is to convert that into a ratio. We're going to take that 23.4, the word, the symbol, percent, meaning over 100, over 100, done. The decimal versions are what people would usually consider the most popular. The decimal version of the word percent is the 0.01. And if we go through the trouble of working out that multiplication, we get an answer here, 0.234. Notice that we have the same numbers showing up, but our decimal point's in a different location. And we can use that observation, we can use that pattern to come up with a nice way of working back and forth between decimals and percents, which we'll do in just a moment. The least favorable thing, basically a last resort, or if my work or my directions force me to do this, the connection between a fraction and a percent. Well, the percent as a fraction would be 1 over 100. That creates an issue with this particular example. The 23.4 is a decimal. I would need to write the fraction version of that to work with the fraction 1 over 100. I would have to then multiply straight across and reduce. And what you can see is that there's obviously a lot more work and time that would be involved in handling the connection between percents and fractions. So a last resort. Since the ratio is very quick to deal with, what we want to try to focus on are the best ways to move back and forth between percents and decimals. And then eventually, in another few more minutes, the ways that we can move best between percents and fractions. Now again, the decimal version's a lot more popular and also a lot quicker. Turns out that the pattern that is going on has to do with moving our decimal point either to the left or to the right, depending on what we have as the beginning number and what we want to create. The nice thing about the way that this all fits together is that we can come up with a table, and that table gives us a little hint about what to do. The word decimal comes first alphabetically. So I put that as the first column, I put percent as the second column, and the connection between these two always involves 2 decimal places. So this is going to give me enough of a hint about what to do. If I am starting with a 34%, I'm going to put that in my percent column. That means I have to move to the left to fill in the decimal column. And moving to the left 2 places is exactly what we'll want to do in order to transform 34% into the necessary answer. So we're going to be taking that 34, we're going to put a decimal point at the end and then immediately move it 2 places to the left so that we would end up creating a decimal answer. And let's go ahead and write that in green. You could say 0.34, or if you're like me and you like to have that extra 0 in front of your decimal point, 0.34. Flip-flop, if instead we're starting out with a decimal number and we want to convert it to a percent, we'll go ahead and take that regular old number and put it into our decimal column. In order to fill in the other part of our table, we would have to go to the right, to the percent column. So that's reminding me that I would want to start with that 4.17. I would want to take the decimal point that already appears and move it 2 places to the right. And that would end up giving me a 417. The thing that I have to remember here is because I'm creating a percent answer, I have to have the word or the symbol for percent. So 417% said out loud, 417 followed by that percent symbol. That needs to be part of my answer. So this gives us a real nice quick way of being able to go back and forth between decimals and percents, making that really nice for us for when we eventually work out problems that have percents. Because we do sometimes have directions, or we just simply have no other choice as we're working through a problem, we will need to move back and forth between percents and fractions. So to start with, let's look at taking a fraction and changing it into a percent. So this first example here already worked out to kind of give us the idea of the best, the cleanest way of working through this. If we're starting with a fraction, and we know already from our past experience how to transform a fraction into a decimal by working out a division problem. Using a basic skill that we have experience with, we're going to get a decimal answer. And we just saw that it's really nice and quick for us to transform decimals into percents, so we can take that decimal answer, turn it into a percent, and we get our final answer here. So we're taking something old, changing fractions into decimals, with a little bit of something new, turning decimals into percents, putting those together back to back and creating the nicest way of converting a fraction into a percent. So to do one of these together, let's say that we're going to look at the fraction 5/11. So we're going to set up the division problem and we're going to create our decimal answer first, which means that in order to actually start working the division problem out, we're going to need to take the division problem, throw in a decimal point, go ahead and raise the roof, put in an extra 0 there. so that we can begin with an actual division question. How many times does 11 go into 50? That has an answer, and that can kickstart the process here. Now, we haven't seen a remainder of 0 or anything repeating yet, so we go ahead and put an extra 0 into our division problem. We're going to take that 0, drop it down, ask ourselves how many times does 11 go into 60? 11 goes into 65 times. See what happens with our remainder. Still not a 0 remainder, so we would need to put in an extra 0. Drop that 0 down and ask ourselves how many times does 11 go into 50? That is a question that we already answered. We said 11 goes into 54 times. So what we seem to be having here is the repeating decimal 0.45 with the 4-5 repeating. Now we would need to take that and transform that into a percent. Might be nice to have a little bit of extra room so that we can move our decimal point. So for instance, if we go ahead and just expand that a little bit more, like so, and then turn this into a percent, we've got room to move our decimal point so that we have 45 followed by a decimal point, followed by the 45 again, and that 45's got that repeating bar over it. This needs to be a percent answer, so we need to say the word percent or include the percent symbol. But this also brings up the possibility that if they give us rounding instructions, how do we work things? The rounding instructions are typically phrased as the nearest percent or something like the nearest tenth of a percent, the nearest hundredth of a percent. That means that we have to have a percent answer to begin with. Before we do the rounding, we have to have a percent answer. So we can take this percent answer and we can round it, the nearest percent referring to the nearest whole number percent that we have. So immediately after the decimal point is a 4. That means that we would keep the number in front of the decimal point the same to give us an answer of 45%. If we're going to round to the nearest tenth of a percent, the tenths place has the 4 in it. We need to use what is to the right of that, which is a 5. My rounding directions tell me that this means that I'm going to round the 4 up to a 5 so that our answer is 45.5%. Again, make sure that you are getting through all of your steps and reaching a percent answer before you worry about any rounding directions that have been given to you. Well, that takes care of one direction. We take a fraction, we do a division problem, get a decimal answer, take that decimal answer, brand new process, convert it into a percent answer, good to go. We need to worry about the other direction where we start with a percent and eventually get a fraction. So again, we'd like to have things work as nicely as possible. So here's the deal. Since ratios already look either exactly or almost exactly like a fraction, and they're quick to come up with, let's use that to our advantage. If we have a percent and need to create a fraction answer, let's worry about converting our percent to a ratio, either at the very beginning or somewhere in the middle, so that then we just do a little simplifying, a little reducing with our fraction, and we'll have our final answer. Now I say that we're going to use that ratio idea either at the very beginning or somewhere in the middle because that kind of depends on what did they give me to start out with. Let's take a look at these two examples here so you can see kind of what I'm getting at. The first example, 3.25. Well, 3.25 is a nice, comfortable sort of number for us. And as far as a percent, we're transforming that into a ratio very quickly by saying percent means over 100. So the percent symbol telling me take the 3.25, put it over top of a 100, and that gives us a good start. Our official definition of a fraction says that we would have to have an integer on top and an integer on the bottom. We don't have an integer on the top. But we can do a little bit of clever work. We've said before that if we would like to make a change to the top of a fraction, we can do the same thing to the bottom. If we make a change to the bottom of a fraction, we can do the same thing to the top within reason. I have an issue with the decimal point up there on the top, and we said a little bit ago, it's nice to be able to move our decimal point. Let's see if we can try to use that idea to our advantage. I'll take that 3.25. If I could just very quickly take that decimal point and bounce it off to the end, then I would create 325. Well, turns out that that's basically meaning that we're going to be multiplying by 100. So we can take that 100 in the denominator and basically say the same sort of thing. Take the decimal point, slap it on the end of the 100, move it 2 places to the right. What I did to the top, I also did to the bottom. And by doing that, that means that we've created a bottom number of 10,000. Now we do have a legitimate fraction. We've got an integer on top, we've got an integer on the bottom, so that's officially in good shape. The only other thing to worry about, as always, before we commit to a fraction answer, can I reduce? Can I simplify that fraction? Well, try to make this nice, 325. 25 will go into 325, and 25 will definitely go into the 10,000 on the bottom. So 25 goes into 325 13 times. 25 goes into 10,000 400 times. Nothing else will go into both the top and the bottom, so we have a fully simplified final answer. That is a fraction, 13 over 400. The next example here, very different though, in what we're starting out with, and less nice as far as most of us are concerned. I'd rather not have to deal with mixed numbers because I don't like them nearly as much as I might like regular decimals. But we did talk about how we can convert mixed numbers into fractions. Since we want a fraction answer, let's go ahead and at least start with that very basic idea from our past experience. Let's transform that mixed number into a fraction. We take the whole number part times the denominator. We add on the numerator. The denominator stays the same as it was. We still haven't touched the percent symbol here, so we're waiting to deal with that for just a moment. What we end up with is a 200 over 3, and there's that percent symbol that we still have to work with. Well, that percent symbol is the next part of what we're going to handle. The percent symbol means that we need to have over 100. Well, when we read off what we already have the word over being represented by having 200 over 3. So that takes care of part of what I need. I need the over. The other part that I need is 100 over 100. So if I've got the over, and I've got the 3, I gave that away already. I've got the 3 on the bottom. All I also need to have said and written down is this 100. So if I got a 3, and then I say 100, what am I really going for? Well, 300. And again, before we decide that we've got a final answer there, we ask ourselves, can I reduce? Slash off the zeros at the end, slash off the zeros at the end again, and this very quickly reduces down to the fraction 2 over 3. Cannot do any more with that, so we have a simplified final answer that is a fraction. Depending on what you have in your original percent, you may want to immediately use that ratio idea, over 100. Or you might want to do a little tinkering first before you, somewhere in the middle, use that ratio idea of over 100. Depends on what they give you. But again, we're looking for something that's nice, that's the best that we can do based on our knowledge, and trying to make things as direct as possible. So, a little bit of that conversion to a ratio, a little bit of simplifying with fractions, that's about the best we can make it.